Hey guys, in this video we are going to cover this bitwise vertical operator
In here you have
AND, OR and XOR, and besides these three you also have bitwise complement and shift operators. Now as a beginner you again would get confused between this single ampersand and the double ampersand. Okay, and likewise the single pipeline and the double pipeline. Okay, now the double is used to represent the logical operators and the single is used to represent the bitwise operator. Okay, so bitwise operators are used to performing manipulation of individual bits of a number. They can be used with any of the integral types like byte, int, char, etc. As a beginner you would not use these heavily, but just remember these would come handy when performing update and query operations of binary index tree. Also, we require basic knowledge of binary number system and how to convert binary into decimal and vice versa. These days, there are a lot of helpful sites available over internet to does this conversion for us, and we'll check few while writing the code. So let's get started. So this is the website, and you can convert
decimal into number, and we have got many options in here, but we would work on decimal and binary only. Like I enter decimal 10 to be converted into binary, and
then you click on this convert and this is what you get. So 1010 is the binary representation of decimal 10. Likewise guys,
so this is one website when you can run all the bitwise operations.
this is bitwise calculator. So you say, okay, hey, the number that I'm putting is of type decimal, okay, and then accordingly you will perform different actions. So for example, if you have to say shift right, so you say 10 and number of bits to be shifted is 2, and then you click on calculate. So we'll see that. Okay, and this is part 11 of this video series,
So guys, you have to select part 11 branch.
right? And this is the file that we are going to work upon. Okay, so let's get started. So we have these two numbers 10 and 20. We just saw the binary representation of 10. Okay, let's see the binary representation of 20. So in here you set it to 20, you click on convert, and this is what you get 10100. So we go back to our code and we see 10100. All right, and the first operator is bitwise OR. This operator is a binary operator and it is denoted by pipe character. It returns bit by bit OR of input values. That is, if either of the bits is 1, it gives 1, else it gives 0. So this is 10 and this is 20. Okay, now we are using this bitwise operator, and this is how you do it. So 00 is 0, 10 is 1, then 01 is 1, 10 is 1, and 1, and this will become the 0. So 01 will again become this. So the output of this would be decimal 30. Okay, so if you print it, so bitwise OR of 10 and 20 is, so this is how you have to do. So you say this is an expression and you say 10 bitwise OR 20. Right guys, so this is the outcome that we are expecting, decimal 30. Then comes bitwise AND. This operator is also a binary operator and it is denoted by a single ampersand character. It returns bit by bit AND of input values. That is, if both bits are 1, it gives 1, else it gives 0. So we say 10 and 20. Okay, so in here now you see 00 would be 0, 10 would be 0, all right, and so on. So it gives 1 if both the bits are 1, otherwise it gives you 0. So the output would be decimal 0. Okay, so 10 bitwise and 20 would return you decimal 0. Okay, let's check this out. So we said I want 10 and 20. Okay, let's do the AND first. So we get 0. Okay, this is what we said. If you do the OR, you get 30. Next comes bitwise XOR. This is also a binary operator and it is denoted by this circumflex character. It returns bit by bit XOR of input values. That is, if corresponding bits are different, it gives 1, else it gives 0. So let's look at this. This is 10, this is 20. So these two bits are same, 0 and 0. So we get 0 back. Now in here you have 1 and you have 0. Alright, so they are different. So you get 1 back. and so on. So you get decimal 30 back. Let's look at the website now. So we are doing Zoc. So you click OK and you get 30. All right. Then comes guys bitwise complement operator. This operator is a unary operator denoted by this tilde character. It returns the ones complement representation of the input value. That is with all bits inverted, which means it makes 0 to 1 and every 1 to 0. So in here, it's a unary operator. So we are saying, give me the bitwise complement of value 10. Okay, and when you do so, you get decimal 5. But guys, compiler will give 2's complement of this decimal value 5, which would be minus 11. Let's check that. So come in here. We say, okay, this time I'm going to do not, right? So we calculate and we get minus 11. All right. So that's what we are expecting. Now guys, we have shift operators. These operators are used to shift the bits of a number left or right, thereby multiplying or dividing the number by 2 respectively. Now the first one guys is signed shift right, which is denoted by 2 greater than. Now this shifts the bits of the number to the right and fills the void left with the sign bit. So for example, you have this 10, okay, and you say 10 shift right 2, okay, so you get 0010, okay, so this is being shifted to the right and we get rid of these two and add 00, okay, in front of that. So therefore you get decimal 2 back. Let's check that out. So we have shift right and we say
10.
and then these are the number of bits we want to shift. We calculate, we get 2 back. All right. Then is signed shift left and we use 2 less than sign correct. Now this shifts the bit of the number to the left and fills 0 on voids left as a result. So guys, you have this, all right. So you shift 2 bits left, okay. Then what do? You add 20 in here, okay, and then you get decimal 40 back. Let's check that out. So we say shift left by 2 bits, okay, we calculate and we get 40 back. All right, so this is what we are expecting. All right, so let's save everything and execute our program.
Now guys, you can compare this result being shown in this console with the result mentioned in the comment. Okay, and with that we have completed the bitwise operators in Java and have also concluded operators in Java. I'll see you in the next video.